running Kubernetes in production for a good couple of years, and for both customer products and also internally as a way to help our development teams run faster. And my role within the company is to try and make good technology decisions, as I'm sure we all do. And with functions as a service being pretty much at the top of its hype cycle at the moment, then there's a lot of interest in whether we should be moving with this new paradigm, whether we should be, sticking with what we do at the moment. What are the opportunities? So that's what I'm going to be talking about today. If you're an expert with Faas or you've been using Lambda and things like that, then there's going to be stuff that I'm talking about that won't interest you and you'll probably find a bit tedious, but this is designed as an intro to the topic. So be gentle. Okay, one of the things, the idea with Faas, what do we mean by Faas? Well, we want to cut away the cruft of what we have to do as developers. We're all paid to write code. All of the other stuff is really, it should be unnecessary. In the fullness of time, we say, we want to do this logic, run it please, and that's that. We don't want to have to worry about infrastructure. We don't want to worry about where it's running in the world. We don't want to worry about server uptime or what the operations guys want from us. We just want to run blocks of code. Okay, so a Faas platform allows you to take your block of code, allows you to register that with your Faas provider. It allows you to invoke that code, and that can mean either invoking it with a REST call or responding to some kind of web event. And then ideally, your function, however many times it's called, it will scale on demand. So, we've seen these sorts of slides many times over the last day or two, and I'm sure you've seen them at other conferences too, the evolution of systems design, where we were all 20 years ago, where we had a big monolith application that had a huge database behind it that's difficult to maintain, but it'll live forever, and it's got benefits, right? It's stable. You've handed it over to IT operations, and they run the thing, and you don't have to worry about it. You're probably not on call all the time for it. It's all good. But then, you get new developers into your teams, and you don't really want them tackling an entire monolith on their own. It's quite a scary prospect, and it probably isn't wrapped in the nicest of integration tests or unit tests, because 20 years ago, these things weren't quite so commonplace. So we shift to a microservice architecture, right? And that's why we're all here, Container Days, and we're all running these things on Kubernetes. And we've completely removed all monoliths from all our organizations, right? No one running any monoliths anymore? I see a few smiles. Yeah, we all have monoliths. Unless you're a startup, and in which case, lucky you. This is a nice place to be. Okay, and if we're to believe the hype cycle, then we're leaving this microservice world behind, perhaps, and we're instead introducing just a load of functions. And this is our utopia. We don't have to worry about services that are running. We don't have to have monitoring, where we're constantly looking for service uptime to run our discrete bits of code. It's just functions, yeah? They're going to be there when we need them, and that's all that matters. And we'll throw in a few events in there as well, because that will make things much easier for us. And you might detect a slight tone of sarcasm in my voice, because really, although it makes what we're running much more simple, we're sort of avoiding all of the cruft about how those functions are connected, right? And that's half of what we do as programmers. We integrate things. And the functions, whilst it solves one problem, it removes the infrastructure wrapper around what we're doing. And I include what we do in Docker containers with that as well, because in Docker containers, obviously, we're basically having to include whichever OS libraries we want, and we're having to make sure they're kept up to date. And functions as a service promises to remove us from that world. We no longer have to worry about that, which is not really true. So there's a tendency to look at functions as a service a bit like this. It's like we're currently doing microservices, and there's this new shiny thing, and it could be great, right? But I guess that some of you here, you've seen the shiny, and you're thinking about whether you should probably be investigating it and doing it in production. And I think what I've discovered as I've been using Faas frameworks for the last 6 months is that the reality perhaps isn't like that. We're not throwing away microservices. We're not saying, well, that stuff you're doing with Kubernetes, with your containers and your pods and your Docker files and so on is completely irrelevant now because we've got the new shiny functions as a service system. We're probably more looking along the lines of a bit of a jumble of opportunities here. So we've got our microservices, they're very much still a part of what we do every day. And we're also looking at new ways of working. We're looking at event systems. We're looking at functions that respond to events, so we don't have to be running microservices all the time, and certainly not maintaining some kind of API endpoints that we don't strictly need, because all we want to do is really run code. And let's face it, the reality is probably that we've still got some lingering monolith there. If we're an older company, there's this old cranky thing that hasn't been updated for, well, longer than it should. And we want to modernize this, right? You know, we don't really want monoliths, but they've been around for a long time, and unless your company's quite young, you're probably having to deal with the reality of maintaining that. So really what we end up with is we end up with microservices which take away some of the chunks of code out of your monoliths, but then we end up with functions where we can extract clean blocks of code from our microservices or our monoliths, extract them, and then they're maintainable in isolation, right? You can test them more easily. You've proven that this block of code is functional on its own. It's not going to be affected if the monolith goes down or if something else needs to happen on your platform. So functional use cases. Now, you will, if you read the hype online and you read about, the ways you can work in a serverless environment. And let me just touch on the word serverless here. So functions as a service are a serverless paradigm, okay? But serverless is much broader than just functions as a service. Serverless encompasses PaaS to a certain extent, it encompasses events, it encompasses a number of other utilities. So whilst you can say that function as a service is serverless, all of serverless is not function as a service. Okay, so things that you can use functions for, and the things I've found real use from functions is for heavy lifting. So processes which are typically quite CPU intensive, RAM intensive, they're long-lived, or they run infrequently, but when they do run, they create heavy load, is a really nice opportunity for a Faas environment. Because if you look at the alternative, you're going to run a microservice, right, which has an API in it, it's got loads of utility within it. And it's probably got quite a broad spread of functionality in there. Now, if your microservice is doing lots of things, and there's one particular functional endpoint which is CPU intensive, you don't really want to have to scale your microservice to 100 replicas just because there are one or two functions in there that are really consuming resource. It's far nicer to run a smaller set and then offload that function to some other service. Now, without functions as a service, what you're really doing is you're saying, well, I'm going to create another microservice which just wraps a single function, because then I can scale it independently from the rest of my stack. And what Faas allows you to do is it allows you to say, well, yes, I'm going to do that, but I'm just going to wrap the function. I don't have to worry about creating my own API endpoints, my own monitoring, my own metrics about how long the function's running and how many times it's being invoked, and then introduce some autoscaler on there. Ideally, my Faas framework is going to do that for me. Other things that people tend to turn to Faas for: stream processing, binary file manipulation, machine learning topics where you're using a model to do some kind of analysis. And again, depending on the load on your platform, you might need 100 of these, 1,000 of these, or maybe none at all if it's not being used at that particular time. And you don't want to be running it constantly. And ETL transformations, so the sort of thing that you might run where you're extracting data from a particular database, you're doing some transformations and you're dumping it somewhere else. A really nice opportunity for Faas because it can be invoked when there's new data to process. It can dump the data and then it disappears again. It's completely ephemeral. Okay, so events and integration points. If you're using AWS and you're using Lambda or something like that, then Amazon provide all sorts of events that kick off when you upload to an S3 bucket. You can respond to that event, you can do some processing on the data that's been uploaded, maybe dump it back to S3. And there are all sorts of other events that you can hook into. They also have a whole suite of services, queues, and other clever databases and things like that which you can integrate with. And that makes the functional paradigm really work, is when you've got good integration points. Because your function itself, it's not going to be dealing with persistent storage. It's going to be taking something from somewhere, doing something with it, and then it has to offload it either to a message queue or to a database if you really must, but to some kind of other service. So really it's these integration points that can make it work for you. So before I go on, what are events? Well, events, webhooks are events. When you have pushed your Git repository and you get a webhook to say it's happened, that's an event. And it's calling it by a more generic term, but that's really what an event is. And events from GitHub or whatever, they can be fanned out using an event gateway, and Serverless do a great event gateway. I don't work for them, but it's great, which allows you to consume an event and then fan it out to multiple event consumers. And really what we're saying is that, well, your function can be a consumer of these events. When someone tweets, not that this is a particularly good example because there are no Twitter events, but you can write a microservice which could generate an event from Twitter being posted, or someone uploads to an S3 bucket, then it will basically take the heavy lifting out of starting that function for you. You've got this event, you consume it, your system will invoke your event handler, your function. That'll do something with it and load it somewhere else. You don't have to be running a microservice all the time to handle this. So you've got this really nice environment where you can create or you run code on demand, but it's not there all the time just waiting. It's not having a service that's sitting there that you've written, which you're constantly having to monitor. If you write a new version, register the new event, no problem. You don't have this deployment cycle challenge. Well, you have a different deployment cycle challenge, but I'll come on to that later. Okay, and there's cloud events, which some of you may have heard of. Have you heard of cloud events? Basically, they're providing, or they're trying to push towards a standard for the payload in these event hooks. So at the moment, even events within Amazon's system often differ between which services are producing the events. And what cloud events are trying to do as an open standard is to say all events should look like this. And they will make it much easier to consume events on multiple platforms, launch your functions, and just treat this information that you're getting from the event in a standard way. So you don't have to write a function which specifically responds to events from an AWS platform rather than Azure or from your own internal services. Cloud Events is attempting to provide that standard. Okay, so to give you a couple of examples, I've already touched on this, but imagine you've got an object store. This could be S3, or it could be Minio, maybe running on your own platform. It could be any of the other object stores. An event gets emitted from the object store to say, hey, a new binary has been pushed into this bucket. We're going to invoke a function which processes that binary, which I've stated as an image here, and then maybe push the result of that back to the object store. Or maybe we push it to a database, or maybe we actually kick off another event, which is then consumed to deal with that new image. You've got this really nicely decoupled flow. So you're no longer writing a function which says, right, okay, I'm going to poll S3, I'm going to collect any images that appear there, then I'm going to make an API call, and I'm going to wait for the API call to respond, and then I'm going to hook things up this way. Instead of doing that, you're saying, okay, I'll just wait for an event. And when the event comes in, my function gets launched, it does its thing, it puts the thing somewhere else, and then it disappears again. I don't have to worry about this sort of longevity of my service, which is only being there because it's doing some polling task or some pushing task. Another example might be that you've got an online channel, maybe you've got a Slack channel, or you've got some GitHub comments, or you've got Twitter, for example, you've got a message coming in. You don't care about the 10,000 messages which aren't really saying anything much, but you might push it through a function which does sentiment analysis and just does some machine learning type thing to say, is this a happy message or is this a sad message? Is this someone with a problem? I know most of us run companies where no one has any problems, but just imagine an environment, if you will, where someone's posting something which is negative. You can do some sentiment analysis automatically, and then maybe you push a ticket into a Jira queue if you detect that it's doing. It's this sort of connectivity of things really that you get from functions as a service, because you're writing a block which is responding to an event, doing something useful, and then disappearing again. And you can build up this huge tool set potentially of these events where you're not paying for a long-running server that's running somewhere which is running your service and doing its thing. You're literally just using resource when that event is spawned and needs dealing with. Because obviously, for 364 days out of the year, you're never going to receive any kind of negative press, but then that one time. Okay, so let's have a quick look at the Faas ecosystem. What functions as a service providers are there out there? Now, AWS Lambda, I presume if anyone's looked at Faas in this room, then they know about Lambda because it is the biggest by far Faas provider. They got there first, and I've heard stories about how they came up with Lambda. But one of them was that they noticed that a lot of people were spinning up a server on Amazon's Web Services. They were doing a short-lived task with it. Maybe they were using it to orchestrate some other services within AWS, and then they were shutting down the server again. Now, AWS Lambda cuts away all of that. It just says, right, well, just run the code when it's needed, right? Start the server, do the code, shut down the server. And functions as a service at a very simple level is just that. It's create me the resource to run this function, then shut it down again. I don't need it after it's run. Of course, the other cloud platforms also have their own Faas products. You've got Google Cloud Functions and you've got Azure Functions. But what if you want to run your own? What if you've got some kind of private cloud requirement here, or you're dealing with sensitive data and it's not allowed to leave your network boundary, or you want a bit more flexibility with how you run those services? Well, the CNCF list lots of functions as a service providers. If you go to s.cncf.io, by the way, it will give you the landscape for serverless. And as part of that, there is a block for functions as a service providers. Now, these ones that I've included here, they're the ones that I've been aware of the longest. With such a fast-changing landscape of Faas, there are Faas things that are even listed on the CNCF that have only been around for, well, 6 months. These guys have all been around at least a year, so they're the old guys. OpenWhisk was around actually before Kubernetes. It was, yeah, it's probably the old one there. There was a talk yesterday on kubeless. But I'm going to talk about OpenFaas. Now, I'm not doing this talk as a recommendation of OpenFaas particularly. I'll show you how to install it and how easy it is, and also to try and cut away some of the magic of function as a service, because it shouldn't feel magical. It's quite a simple idea. There are many ways of achieving the Faas goal, and OpenFaas is a nice and easy to see, transparent way to just work through the whole life cycle. Okay, so I've got my function. It's in sort of pseudo Python. It does some stuff and it makes some profit, which is obviously what all our functions do. That function will run within a container, and in the OpenFaas environment, you also have control over what that container's environment is like. And one of the key things I like about OpenFaas is that there are no restrictions on what you can do within that container. You can use environments, you can use secrets and config maps if you want to. You can still run containers configured in the way that you like to run containers on your platform. And what we want to do with that function is we want to be able to trigger it easily. We want to observe how many times it's executing. We want to see how long it takes to execute, how many errors we're getting. And we want to be able to scale it. And we want to scale it independently of other functions that are running on the platform. And the OpenFaas framework, as with other Faas providers, they do those things for you. You get that for free. So if you're writing your own microservices, then you have to do that yourself. You know, okay, you can use Kubernetes and you can use auto-scaling and so on, but you're still having to configure that stuff yourself. What OpenFaas as a provider does is it allows you to basically chuck loads of these functions at it, either ones that you've written yourself or Alex Ellis, who is responsible for the OpenFaas project, is pushing for a repository of publicly available functions in much the same way that Docker Hub does. So if I just quickly show you how OpenFaas works, what it has is several components. It has the OpenFaas gateway, which is your API endpoint. It provides a route for every function that you register with it in a very simple way. It's just an HTTP URL /functions / your function name. You chuck the data that you want the function to execute at it, and it will return you the result. It's as simple as that. And it will invoke function containers of your own creation on demand. As part of it as well, it installs a copy of Prometheus and Alert Manager, which basically is looking for the telemetry information. So it's feeding in how many functions are operating for each different function, how long they're taking to execute. And it uses Alert Manager as a way to say, hey, if this threshold is passed, then we probably need more containers to handle the load. It also uses NATs. Familiar with NATs? Just a queuing messaging system backend. And one of the things that OpenFaaS also allows you to do is to execute functions asynchronously. So rather than making your call and blocking while the function operates and then receiving your result, you can invoke functions asynchronously and say, hey, when you're done, call this URL, and it will make a request there. And again, this is where events comes in, you see, because you can use an event to trigger your function, and you can use the asynchronous functionality to trigger another event, which could hit another function, or it could go to another system. You've got this really nicely, loosely coupled set of functionality. Okay, so how does this work? OpenFaas's key selling point is the fact that it can turn any container or any process into a function. And it does this with a watchdog process, which you install inside your container. You can do this with absolutely any container you've got. If you've got a process that runs in there, you install the watchdog, and all it does is it runs a very, very lightweight HTTP server inside your container, and that's the port you expose from your container. Any input to this HTTP server is transmitted to the process of your choice over standard in. Yes, it's really that simple. Then your process does its thing, it responds over standard out, and the HTTP server watchdog returns that result to the Faas daemon. Okay, so I'm going to show you how to set this up. I have to make a confession. I'm not very good with live demos, so bear with me. Everyone said it was a very, very bad idea, but, you know, to hell with it. First of all, I have to get this onto the screen. Oh, look at that. Is that big enough for you there? Can you see that at the back? Yeah, okay. So the first thing we're going to do, I've already got a Kubernetes cluster, which I installed through, well, my company runs Kubernetes clusters on demand, so I just got one through there because it's free for me. But if you want one of your own, then our stand is over there. But that's already done. So with my Kubernetes cluster there, I clone the Faas repository. I said live demo, didn't I? I'm sort of cheating because I'm not really typing. So we clone this. I apologize for the speed of it cloning. I was doing this over a hotspot connection on my phone yesterday because I realized that I probably should record it. So we've got some YAML files here. You can also install this using a Helm chart. Are you familiar with Helm? Yeah, it's just a single one-click install effectively for the whole Faas system. You'll notice we've got the gateway, which is the actual inbound HTTP server. We've got NATs, we've got Prometheus, we've got Alert Manager, which is the thing which will trigger for it to create more containers for us. We'll see that in operation in a minute. And I've got an empty Kubernetes cluster. Okay, so now we're going to apply those YAML files into two namespaces. Now, one of the things I like about OpenFaas is that OpenFaas installs into its own namespace, so it's nicely isolated. So you get Prometheus in there, you get the OpenFaas daemon and all that sort of stuff. But then it deploys your functions into an OpenFaas FN namespace, which means that it uses RBAC to control what it's allowed to do. So it's a nicely secure way for it to create your containers. So we'll create the namespaces there. And then we're just going to apply all this YAML and trust that it's doing the right thing. We've now got that in our container, in our cluster. And we'll see it's created there the suite of services that make up OpenFaas. And there's nothing in the OpenFaas FN namespace because I haven't actually created any functions yet. Okay, it does configure ingress controls if you know about that stuff, but I'm cheating, so I'm just using node port because I'm lazy. So now I've got Prometheus and I've got the gateway service. So let me just go to show you what gets created there. There we go. So we have a nice user interface. Well, we have a user interface at any rate. This is the OpenFaas portal. This is just using the normal OpenFaas API behind the scenes. There's also a client tool, which I'll show you in a minute, which we can automate stuff with. And actually, in incubation at the moment, there's a Kubernetes operator, which will allow you to create functions using the normal kubectl functionality, which is obviously an important step towards GitOps if you've done any of those talks, because you really want to be thinking about how your configuration is committed into Git as much as anything else. And in here we have Prometheus. Everyone familiar with Prometheus? Vaguely, that sort of thing. And inside Prometheus, you've got Alert Manager, and you'll notice that there's an alert up the top here, which is basically saying if any of the functions, so by function name, if any of the functions over a 10-second window, if there are more than 5 operating every second, then we want more containers. Now this is configurable, and it's basically to say how excited do you want it to be about auto-scaling your functions. Okay, so let's write our first function. And again, I'm cheating, because I figured that actually trying to type in a terminal when it's behind me is probably quite challenging. Okay, so I'm creating a demo function. I'm just going to write a little bit of Python. OpenFAS client, which you download using the link that's in the OpenFAS user interface, allows you to do stuff in a very Kubernetes-like way. Yeah, you know, you're used to using kubectl. This is effectively the FAS equivalent. But as I say, they're actually developing an operator to allow you to use kubectl. And there's the most important functions here are new, which allows you to create a new container definition really simply. Now, what I said before is that you can install the watchdog in your own Docker file, and that's completely doable and completely fine. But the FAS client cuts away all of the necessary work that you would have to do there and allows you to take just a block of functional code and put it into a container, so you don't have to be doing that yourself. Okay, I'm telling it I want a Python one, and I want the prefix to be Steve Mayne. Obviously, you probably want a different prefix for your functions, but this will become the Docker image name, so it'll become Steve Mayne / the function that I'm creating. Okay, and I've invoked new, and I've got myself a YAML file which defines what the function is, and you'll notice all it's got here is that the language is Python, the handler is in the container days folder, and I'm going to create the Steve Mayne / container days Docker image at the end of this process. There's nothing else in there. It also creates a directory which contains my handler script, which is just my function. So if we have a look at the handler py, eventually, there we go. All it is a very straightforward function, and I can fill that in with whatever I like. There's also a requirements.txt, so I can install libraries and things like that. I'm just going to hack this around for the sake of showing the auto-scaling working. I'm going to do a very simple modification to handler py, and I'm going to get it to sleep for a little while so that auto-scaling works. I tried DOSing my FAS cluster yesterday over the conference Wi-Fi. It didn't really DOS, and so it didn't auto-scale because it was so slow. Okay, so all I'm doing there is I'm sleeping for 1 second, and then I'm returning hello with the argument. It's not the most exciting function, and I apologize for that. Then once we're done, we can then build that. And all build does is it takes that simple definition handler py, and it uses a templates folder, which you can define yourself, but one will come down from Git if you don't have one yourself, which takes the language Python and incorporates my... Oh, look, it's done the build. Sorry, I should be watching. It incorporates my handler py with a wider Docker file definition to actually invoke that function and install the watchdog and that sort of thing. And then it uploads it to, or rather it builds the Docker image. And then again, conveniently, we've got a push function, which all it does is uploads to Docker Hub. Again, this is all configurable. You can change which registries you're using. It's not hard-coded, but there are handy defaults in there for you. Layer only already exists because I've done this a number of times. So, you probably see a bit more push activity going on. And then last but not least, okay, there's a list command, which will show you all the functions that are registered, which will be none. Okay, I've got no functions at the moment, and then I can deploy that function that I've just created. So I can set an environment variable which allows me not to have to specify the gateway every time, which is also convenient. Always goes much slower when you watch it. Okay, so what have we done there? I've deployed this from the container days YAML file. That's just registered the Docker image I've just created with the Open Faas gateway. And then I've invoked it using, hang on a minute. No, I haven't got there yet. That's a preview of coming attractions. I really am a slow typer. Okay, so now I can invoke it, and the gateway is so simple. It is just an HTTP server which is taking input, creating a copy of your function for that, to handle that, and then running it. So I can invoke it over curl. This is the gateway URL here, and my function has its own route for container days, and I get my response. And it really is as simple as that. So without further ado, because I've just seen the flashcard for the amount of time I've got left, let's get this to scale. So what I'm going to do here is taking that function, which takes a second to execute, no matter how fast my cluster is. You'll notice it's running a single pod for my function to start with. Now, as with Kubeless, it will create you a pod for every function you register with the service. And there is talk about maybe scaling down to 0, so that if a function doesn't get hit particularly frequently, it'll spin it up on demand. But at the moment, you get a minimum of a single pod per function that's registered. I'll just run a separate screen here so that I can run Apache Bench and hit that function a few times. So there we go. I'm running Apache Bench, and I'm running 20,000 requests against that function with 50 concurrent threads, although it's not actually being hit that hard because, as I say, I was doing this over my phone yesterday in that room over there, and sadly my internet connection didn't allow me really to DOS my function. But it did eventually get going. So we're running a single pod at the moment, and with any luck, and without keeping you waiting longer than we've got for this talk, we should hopefully start to see some other pods come along and join the party. And there we go, and it's creating the containers on demand to respond to that increased load of the Apache Bench process, hitting it as hard as I can hit it. Now, you can start to see how this could be really useful in an environment where you have a lot of maybe disparate functions that you're running in services, or maybe even some sort of scripted things that you end up with an ops engineer running every now and again to do some data transformation. You can wrap them into functions in containers, and you don't have to run a microservice yourself. You can just put them within the Faas gateway to do that. Oh, it's getting very excited now. Okay, so that's scaling working. I was going to show you what that looks like in Prometheus, but because this was a recorded demo, then you can't see it. But Alert Manager goes crazy, and then you end up with it going red, and it invokes the autoscaler within Kubernetes. Or rather, not the autoscaler, it does the scaling and tells Kubernetes to increase its replica count. Okay, so let's stop that. I sadly run out of time for some of the other demos that I wanted to do. So as some closing remarks, I think what I'm trying to say is this is a useful paradigm, right? It can be useful in a number of circumstances, and it can take away some of this boilerplate code that you as developers or your developers are doing, because every time you write a function that does need invoking in a classic manner, you do currently have to wrap it in a service, and that comes with a significant amount of overhead. So consider taking it out of your own microservices and putting some of these functional blocks in a Faas provider, because then you can just focus on maintaining those functions. So there are some things to consider before you roll Faas out. You go back home and go, this is a great new idea. We've got so many microservices. Let's chuck them all away and let's just put our functions into a Faas provider. OpenFaas is easy to install. You can do it in a few minutes. So let's just do that. there are some things coming which are quite exciting. Kubernetes Operator is one that I'm looking forward to particularly because we should be doing configuration as code, right? We should be doing GitOps. We should be making sure that no one is running kube control on the live production platform. We want to be able to reflect our test environments on live and so on. So that's quite exciting. Multi-tenancy as well. At the moment, OpenFAS has a single authorization username key, but in future they're going to support multi-tenancy. I say they, it's an open project, so get involved. They're going to add open tracing support so that you can follow through your paths. I don't know if you're using Istio or anything like that, but if you're using any kind of tracing, you really want to see where you're hitting those functions, how long they took inside the functions before they went elsewhere in your system. That's coming soon. As I say, scaling 0 to 1, there's some conversation about whether this is really something that needs to be done, because in the general scheme of things, it's not a huge amount of resource. But personally, I would like to see functions that are run once every week, not to be taking up resource on the platform. And what I think will really turn this paradigm into something that we're all using is increased use of standards, and cloud events is one that I'm really looking towards as providing this ability to say, this is how you describe an event. And if I pump that event into an event gateway and it gets spread around the world, I want to be able to send the same event to several systems, maybe to my functions, maybe to some microservices, and have events represented in a standard way. Because once we've got that, then really I think this interconnectedness of multiple functions and having truly decoupled functions is the dream that we can live. But there's still a very big role for microservices, and I think our monoliths will also be around for an awfully long time as well. So may they live in harmony for a long time. And that reaches the end. Do we have any questions? It was all completely clear, or boring, or good. Oh, that's fantastic. Thank you very much.